So in the last week, we had discussed about adding of two 32-bit numbers, okay, wherein we looked at loading the resistors R0 with a certain value and then R1 with certain value, and then we used add as the keyword, and we were able to get the results in R2. So I think by now you know which is your source registers and which is your destination. So this is going to be your source and this is going to be your destination, right? And we also saw that the results were all in hex. Okay, fine. So today we'll move on to the next program. Okay, and that is talking to us about the addition of first 10 numbers. So generally, how do we do this? We add 1 plus 2 plus 3 plus 4, okay, so on, plus 9 plus 10, and we should be able to get about 55. Okay, can someone just confirm, are we getting 55? Quickly take out your calculators and add those numbers from 1 to 10. Someone on it? Can someone check and tell me if we are getting about 55?
Yes, sir. 1 to 10, we are getting 55, sir.
55, no? Fine. Thank you for confirming, Govind. So, so we'll be using Keel Microvision. I hope by now all of you have installed it on your systems, right? And there shouldn't be any glitch, right? Okay. So we are going to start off with adding of the numbers, okay, before which we will just look into the algorithm, okay. So we'll initialize the code area, okay, then we'll link the program code to the processor, then we will load the values, and then we will add the values and store the result. Fine. So here we are looking at about 4 registers, okay. So I want you to just make a note of it, okay. R0, R1, R2, R4, okay. So these 4 registers we are going to use. Fine. So these are the initializations, and yeah. So we are going to load the register R0 with 10, okay, because we are told to add first 10 numbers. And then we need to have the 0 count also. So R1, we are using that, okay, we are using R1 and we are putting 0 there. And we are using R2, okay, to slightly increment these registers. So R2 is also given with 1, okay. Now is the thing where your execution starts. So initially you had R1 is equal to 0, and then R2 is equal to 1, and then R1 is 0. So you are adding 0 plus 1 here, okay, and the result is stored in R1, okay. Now next you are incrementing R2 by 1, okay, which means you're adding to the contents of R2 by 1. So which means 1 becomes what? If I increment R2, if I add 1 to already existing 1, then it becomes what? R2 is equal to, right now, once it has entered the loop, how much is the value of R2?
2, sir.
2, correct. So R2 becomes 2 here, okay. And then the next thing I'm bringing is R4, okay. So this R4 is brought so that I will have a count, okay. I will know that when to stop adding, okay. So this R4 is acting like a counter, okay. So R2 will have certain values, say for example 2, okay, and minus R0, okay, minus R0, so which means 10. So 10 minus 2, so which means it will know that the branch is not equal to 0. R4 is not equal to 0. So the loop has to go on again, right? So this loop will break. This loop will break when it becomes 0. Okay, when the difference between R0 and R4. So 10 minus 9, then it becomes 10 minus 8, 7, 6, 5. So when it, so we are trying to look at 10 minus 10. So once it becomes 10 and R4 also becomes 10, 10 minus 10, then it becomes 0. Okay, so that's when this branch is broken. And
sir, what is the D and E, sir?
A branch not equal to 0. Okay, so we have certain instruction sets here. Okay, and you will have to look into it. Okay, so there are a lot of instruction sets here. Okay, probably I will try to share this in some time. Okay. Yeah, we should be having it somewhere here. So it is looking at branching. Okay, so just like jump if 0, jump if not 0, right? Jump if equal to. So here we are using branching operations. Okay, B is used for branch. Okay, so it is checking for the value of R4. Okay, and as I told you, R4 is acting like a counter here. And then once that becomes 0, okay, now remember we are doing a subtraction here, right? We are doing a subtraction between R2 and R0, between R2 and R0. So here R2 is getting incremented, and here R0 remains constant. So R2 becomes, next, in the first cycle it was 1, and then I added #1, it becomes 2. So 10 minus 2 becomes 8. So this 8 gets stored here. In the next cycle again, this becomes 3. So 10 minus 3, so 7 comes here. So it will wait until, okay, it will wait until this value becomes 10. Okay, so that 10 minus 10 gives me 0, and R4 ultimately will have 0. Okay, so once it is 0, then it means this loop, the branch is broken, and then finally it stops the branch and the code is ended. Okay, so if it is not equal, it is going to loop. Okay, if it is equal, okay, then the adding happens. So what is this adding? R1, okay, R1 and R2 both are added. So it is like 0 plus 3, okay, then 0 plus 4, okay, and the value of R1 keeps updating. Okay, so here when I say 0 plus 1, R1 value becomes 1 because the destination is what? R1. Then it goes to the next again. Okay, the same thing continues. So here my final result will be stored in R1. Okay, and R0 will always have 10 because the question is asked for 10. Suppose I say the question addition of first 20 numbers, then I'll have to change from 10 to 20 here. Okay, so our final value, that is, we are going to get it here. Okay, and what is the maximum value this R2 can attain? Can someone tell me if you have understood the code?
10, sir.
10, correct, right? Because we are adding 0 plus 1 plus 2 plus 9, okay, plus 10. So 10 is the maximum value that this R2 is going to attain. Fine. So we are going to see the results here in the form of hex, and you're going to see R0 as 10, okay, A, and 55, you do a conversion, okay, you should be getting about 37 in hex, and R2 is going to reach its maximum from 1 to 10. Okay, so I hope you have understood this code, right? So once you start executing, you will be able to understand. Fine, so let me just show you that as well. so that you'll be able to understand as to how this execution is done. Are you all able to see this?
Yes, sir.
Yeah, okay. So I think the process and all, you guys know it already, isn't it? So this is going to be our code, okay? And yeah, I'm going to translate it. Okay, and we have got 0 errors and 0 warnings, and then I build it. Okay, so building a file is also done. Then I get into the debug mode. Small warning message, you can click on OK. And I will be pressing F11. Okay, so you can see that first the program counter is trying to know the location of R0. Okay, and then once it knows where R0 is, then the value is going to store 10. Just see here, this value here is going to change. See, it's going to change. Similarly, R1, I'm going to give clear. Why am I storing 0? It is really necessary because whatever value is in R1, I'm not sure, right? So it's always nice to clear out the values in the resistor. And from then on, you can continue with your process of execution so that you're sure that what you're doing is right. And R2 is stored with 1. Okay, you can see that here. Okay, then the loop goes on. Okay, so you can see that these values getting changed towards your left hand side. Okay, so this is the difference. A minus 3, which is 10 minus 3 is 7. So R4 is having a count of 7. So it again goes to the next loop, becomes, okay, 4 here. So this should become 6, R4. And, it continues, becomes 5. Okay, the difference is 4, 3, 2, 1. Then now, it ends, okay, because it has become 0. And then it comes to the final one. Okay, and then is the end of your program. So if you can place the mouse cursor, okay, on your registers, you should be able to see R0 values A, just as how we had given, and R1 value final we have 37. Okay, initially we had loaded 0, and right now it's 37, and R2 has attained its maximum value. Okay, and R4 is 0. Okay, because it has become 10. Okay, R0 is 10 and R2 is also 10. So 10 minus 10 is 0. R4 is 0 here. Okay, fine. Yeah, now we will get back to our program. Right. So I hope this was understood by all of you. Right? Any doubts?
No, sir.
Fine. So we'll move on to the next one here. Okay, and this is something called reverse subtraction. Now, reverse subtraction is something where, okay, when I do SUB, okay, now the main important instruction is RSP here, reverse subtraction. So normally when I do SUB, it is R1 minus R2 and the result is stored in R0. Okay, so this particular thing is very important here. Okay, fine. So we will just concentrate on these this instruction here. Okay, so as usual, first we are going to initialize the code area, right? And we're going to start by loading the values onto the registers R1 and R2, and we are doing a reverse subtraction here, right? So the code or the keyword that you're going to use is RSB, and the final value is going to come and sit in R0, and I'm doing R1, R2. So I choose a higher value R2 so that I don't have any overflow. I don't have any negative. If not, I'll have to get into the status. Okay, I'll have to get into the flags and then find out the values. So in order to less complicate things, what I do is I take a higher value of R2 and a lower value of R1 because it is R2 minus R1, right? So ultimately my final result is going to come and sit in R0, right? So we are going to have values here. Okay, so R2, as you know, we are giving 2, 2, 2, 2, 2, and R1 we're giving ones. Okay, so the value we should be able to get about the same thing, which is 2 minus 1 is 1. Okay, so we will look into it. So I will remove this. By adding a file. Okay. Yeah. So this is what we want. And build it. Ultimately, what's happening in building? It is trying to link. Okay, it is trying to link between the code and your startup file and all those stuff. Right. So okay. Okay, I get into step-by-step execution. It is trying to know the value. So to R1, the value is shifted. To R2, the value is shifted. And I should be getting my result in R0. So R0 value is updated. Okay. They're all very simple programs, actually. Fine. So I hope there's no doubt here, right? The previous instruction, if I just use SUBS, okay, subtraction, then that is going to do R1 minus R2. But here reverse subtraction is R2 minus R1. Okay, so that's the main important thing that you need to keep in mind. Okay, shall we move on to the next one? Yes,
Yes, sir.
fine, thank you. So this is about the left shift operation. Okay, now I think all of you know this binary values, right? 8421. So as you go towards the left hand side, 1 becomes 2 and 2 becomes 4 and 4 becomes 8. So that's the weightage right? So we will be learning the same concept here, okay, with regards to left shifting the values. So we are moving a value here to R0, okay, and I am going to left shift, okay, this is left shift logical R1, okay, R1 comma R0 comma #1. So which means whatever is the contents of R0, I am shifting it by ones towards the left hand side. So that is the meaning of this code. Okay, so I shift it once, and then the value I save it in R1. So this becomes 1 becomes 2. Okay, you can see here. Then again I shift once. Okay, so it's again multiplied by 2. Okay, and the value becomes 4. Okay, it's a very simple program. It is just like, you should imagine you have a box here. Okay, so this will be 8, 4, 2, 1. So as I shift towards my left hand side, okay, it is going to jump from one value to another value. Okay, so the weightage is actually going to increase if I left shift. Okay, so that's how your binary code is, right? So we will look into this as to how it is executed. Added it. So now I'll be translating the file. Fine, we have 0 errors. Build the file so that linking happens. Get into debug mode. Okay, so here to R0 we are sending an immediate value which is 0x, okay, 0000011. Okay, so we have sent the value, and then I'm doing a left shift and saving the value in R1. Okay, so you can see the values here also as 2. Then again to the same thing, okay, to R1 I will do once more, but I will save it in a different register, which is R2. Okay, so the values are updated 1, 2, 4. So you can probably make use of another register and shift again. So this should be moving to 8, 8. Okay, so I hope you all have understood these programs. Okay, how information is passed on from one side to the other, and how we are manipulating or we are changing data once using these operations such as shifting. Okay, and we have seen the subtraction operation. Okay, and we have also seen how we can do an addition of numbers. So here you can even take first 15 numbers. Okay, so these are general programs, right? So for your exam point of view, okay, we might ask first 25 numbers or something like that. Okay, so you should be able to get it done. Okay, so you can treat this as a general template. Okay, and programs can be of any sort. So the only thing is you'll have to know the logic, you'll have to know the algorithm as to how it is done. Okay, so once you're clear with that, okay, then it becomes easy for you to move on with the stated problem. Okay, and you can continue. Okay. So is that fine? All of you have understood, right? All the three programs. Yes.
Yes, sir.
Okay, fine.